Hello, fellow human beings. This is Robert Roach with the Type 1 Planet podcast. And today I am in a studio. As you can see, I'm not at my desk in my basement. So we might be able to have more and more episodes in this studio depending on the capability of having guests come into New Haven, where I'm currently based, and visit me in person. So it was a pleasure to be able to have my guest today in person, Stafford Sheehan, and Dr. Stafford Sheehan. And I met Staff actually at a pitch competition many months ago called Venture Clash, and he was able to pitch his company to this group of people, and everyone was just blown away, including myself. And so I knew that both his company, Air Company is the name, and also Staff himself and his excellent communication abilities regarding science, regarding technology, and futuristic thought were such a great candidate for Type 1 Planet. And Staff is incredibly, he's renowned in his field. He's a scientist and inventor. I think he holds 10 public patents. He has 38 academic publications, many technical awards. He was in the Forbes 30 under 30. And he's got an amazing background and also an amazing perspective on the science and the technology that goes behind Air Company, which is essentially taking water, electrolysis, and carbon dioxide and creating jet fuel, creating ethanol, basically from the stuff that's in our atmosphere, the things that are currently considered as waste products coming out of factories. Take something like carbon dioxide, and you're able to, through a certain process, create one of the most valuable, most useful things that exist in our culture and in our civilization, which is liquid fuel. And Staff's team has been able to find an absolutely carbon neutral way of having and using and creating fuel. And of course, it takes electricity. It's complicated. It requires economies of scale. It requires new technologies and new ways of formulating our economy that don't necessarily exist yet, in order to take this to an international scale. But the proof of concept is there. It's Staff said it at some point, to go from 1 to 10, that's just a factor of 10, but to go from 0 to 1, that's a factor of infinity. And Staff and his team were able to cross that line of going from 0 to 1, to cross the factor of infinity. So it was an amazing conversation. We do get into futurism, sci-fi. They want to take their technology to Mars. They are working with NASA right now. They want to help feed astronauts as they're in space. And they also want to democratize energy. They want to make something like fuel available to everyone on the planet and not being beholden to, and not being in the hands of the very few, the very, very rich, and the very, very powerful. And taking that energy and making it so that everyone can use it in such a way where it doesn't harm our planet. As you can see, there's a lot of reasons why Staff is perfect for Type 1 Planet. And it was an amazing conversation. I hope you enjoy it. Please reach out to us at type1planet.net. Follow us at Type 1 Planet on our social media. Give us feedback. Give us your ideas, your guests, and potential organizations that you'd like to see on the show. And let's keep going the conversation. Hello and welcome to Type 1 Planet. This is Robert Roach, and today we're here with Staff Sheehan. And Staff, you are a scientist, inventor, and you are one of the great minds behind Air Company, which is what we're going to be exploring in detail today. So thank you so much for jumping on with me.
Yeah, thanks for having me.
So let's just start with the big picture. I'll give a little bit of background. I went to an event, it seems like a long time ago now, called Venture Clash here in Connecticut, which was basically a pitch competition. And I got to watch one of your pitches, and it was by far the one that caught my attention, if not the attention of every person in that room. So I started looking into Air Company after that pitch, and straight across the front of the front of your website, it says the part of the mission of your organization is to extend life on Earth. So I wanted to first ask you, why is this on the front page of your website?
Because climate change is probably the most existential threat we have right now. And, you know, as a business and as an organization, you know, all of the things that we're doing are taking ourselves steps closer to both addressing climate change in the near term, but then making a more addressable, all the steps that we're taking as a business, both in the short term and in the long term. In the short term, address climate change, but in the long term, allow us to have a more sustainable carbon cycle on planet Earth.
Okay, so when you say, let's just specific here, when you say life on Earth, are you referring to human life, complex life, civilization? What kind of crosses your mind when you start using those words?
Yeah, human life, not necessarily just life in general. Yeah, we're looking at extending human life on Earth so that we can continue to move forward as a species.
Okay, so let's start breaking down the primary technologies that you're working with here. What does Air Company do, and why? One of the big phrases that you guys use is you're saying that our planet's most abundant pollutant could potentially be our greatest ally. So tell me about that pollutant and what you're trying to do with it right now.
So carbon dioxide is, the greenhouse gas in the atmosphere that's causing a lot of problems. It's not the most abundant greenhouse gas in the atmosphere. Actually, the most abundant greenhouse gas in the atmosphere is water, but that's already kind of managed by natural cycles, just fine. The greenhouse gas that's causing anthropogenic global warming is carbon dioxide, and that is also one of the basic building blocks of life. So there's a lot of good and there's a lot of, I would say, not so good aspects of carbon dioxide in the atmosphere. You need to have some of it, right? Because trees need to breathe. That's the plant's food. But you don't want to have too much of it in the atmosphere because that can then trap heat from the sun, which can cause all sorts of climate problems. And one of the challenges that we're facing now is that in the last 100 years or so, we've ejected so much carbon dioxide into the atmosphere that we're starting to see a lot of weird atmospheric chemistry happening that's really leading us towards some not so great outcomes.
And this is what at least everyone from our generation has become incredibly, we're very aware of it. It's very much part of our media. It's very much a part of our cultural sphere. Is global warming, is the way that we have our vehicles. The entire electrical vehicle boom is exploding out of this cultural cycle with a lot of weird aftermaths. For example, we have entire populations of electric vehicles that are existing on coal-powered grids, right? And then there's the difficulties with pulling what we need for those batteries out of the ground, and the incredibly problematic ways that they're doing that. So why is it that actually approaching the way that we create fuel instead of, so we're still working with combustion engines, for example, in the Air Company model, you're creating fuel, which we're going to get into. Why are we sticking with combustion engines right now instead of focusing on something that like electricity?
Well, that kind of leads to a question of energy density. And the reason why it all goes down to energy density is for light vehicles, I actually think that electrification is the right way. At Air Company, we don't make, gasoline from carbon dioxide. We make jet fuel. The reason we make jet fuel is because you can't fly a long-haul jet using a battery. The reason for that is energy density. Batteries need too many kilograms of weight to store a certain number of kilowatt hours of electricity. And because you need to have all that weight of a battery, you could never power a long-haul flight. So you'll always need synthetic fuels for flights that are over, flights that are over 30 minutes to an hour, depending on how advanced battery technology gets and how efficient lightweight aviation gets. Mm. But really, you're never going to power significant amounts of aviation, which is around 3% of global greenhouse gas emissions, using batteries. Okay. And that's why at Air Company, we make sustainable aviation fuel to address that. On top of that, there's a much greater interest now in space than there was, 10 years ago. And you're also never really going to launch rockets. You're never going to be able to launch rockets with lighter fuels and things like that, with the battery. Yeah. You need a rocket fuel.
Yeah. So that's physics. You're talking about, like, this is basic kind of you need to have that matter displacement to beat the gravity, right? To get out of the atmosphere. You can't just take a battery and attach a propeller to a rocket and get it out.
Exactly. Yep.
So let's talk about, the actual process itself. This is one of the cool parts of your presentation that I got to see. Your company says that you're inspired by the photosynthetic process of plants. Tell me about what it is that your machinery is doing and how it is that you can walk away with something like jet fuel at the end of the process.
So if you think about it, jet fuel today is actually made by photosynthesis millions of years ago, right? All the fossil fuels that we're burning right now are actually the product of photosynthesis over the course of the last, couple billion years that photosynthesis has been around. One of the interesting byproducts of all that photosynthesis over all that time was oxygen. That's actually all the oxygen we breathe. That's where it all comes from. So photosynthesis is probably one of the most important processes to life as we know it on planet Earth, because that's what gives us really energy in all forms that we utilize, short of maybe nuclear and some new power sources. So photosynthesis is the inspiration for the process in that it uses the same basic chemical equation. Photosynthesis in plants breathes in carbon dioxide, takes up water, and breathes out oxygen and makes a product. And that's what our technology at our company does. In photosynthesis, there are tiny little enzymes in the plant that split water into hydrogen and oxygen. And that's kind of the first step. We have what we call an electrolyzer, and that splits water into hydrogen and oxygen in our process. We then take that hydrogen and transport it over to our carbon dioxide conversion reactor, feed the carbon dioxide and hydrogen into the reactor, and make our products. In plants, there is a complex relay, proton relay, that moves hydrogen and hydrogen equivalents and energy between photosystem 1 and photosystem 2, and in the end, sequesters carbon dioxide by transforming it, into formal species.
So I'm going to take you through it slowly with me saying it back to you so that I made sure that the audience understands. So you're taking water.
Yep.
You're using electrolysis, which is basically you're electrifying the water and breaking apart those molecules.
Yep.
And then out one vent goes oxygen.
Yep.
And out the other vent goes hydrogen, right?
Yep.
And is that oxygen just a waste gas? You're popping it back into the atmosphere, or?
Yeah, right now, all of our facilities vent the oxygen into the atmosphere. On larger scale, we may capture it and sell some of it. Right now, at the scale that we're operating at our company, the economics are such that it just makes more sense to put it back in the atmosphere. Okay. So it's nicer to breathe.
How would you sell oxygen?
Well, like, for example, to hospitals, medical grade oxygen. The oxygen that comes out of our process is very pure.
Okay, got it. Nice. That makes sense.
It's not a huge market. It's not a huge market, but
sure.
it exists. Yeah.
Yeah. And then you're taking that hydrogen, you're taking CO2 from the atmosphere, which I assume needs to be filtered from the other gases. How do you do that?
Yeah. So right now, actually, we capture the carbon dioxide from point sources. We actually take the emissions from biofuel plants.
Okay.
We have demonstrated with direct air capture. Direct air capture systems essentially usually have a sorbent. So direct air capture systems usually have a sorbent. That sorbent is exposed to atmospheric air, soaks up the CO2, but doesn't soak up any of the other gases. And then you move that sorbent into some place where you can desorb the CO2 in a cleaner way. We have operated direct air capture systems, but we don't use them currently at larger scales, just because the economics are very challenging. It usually takes a lot of energy to absorb and desorb that CO2.
So you're hooking straight up to a facility that their process pumps out pure CO2. So you're able to just say, okay, we'll take that. All right, got it.
Exactly. That's what our first commercial plant, our demo plant does that. We actually deployed our what we call our demo plant at a natural gas-fired power plant. So we actually took the emissions from that power plant and turned them into our products. Just literally straight off the smokestack. So that was kind of our first. We did that for about 10,000 hours, a little over a year.
Okay.
And then now we operate using the carbon dioxide from biofuel plants. So
Okay.
more kind of recently captured from the atmosphere carbon dioxide.
So now you've got CO2 and hydrogen.
Yep.
And do you need any other ingredients to get started with, let's just say, jet fuel in this case?
No other reagents.
Okay.
So that's it. We just take the CO2 and the hydrogen, we mix them together, and we put them into our reactor.
And what does the reactor do?
The reactor, inside the reactor, there are catalysts. A catalyst is just a material that makes a chemical reaction happen. And they're kind of our secret sauce at Air Company. What the catalysts do is they make sure the hydrogen and the carbon dioxide can come together in just the right way to make jet fuel. So those catalysts, are just mixtures of metals, really, like earth-abundant metals, so no rare precious metals. And we engineer them. That's what I did my PhD at Yale in catalysis. So that was kind of what I studied for all the time that I was here.
Okay.
That those materials are, things that we make in our laboratory. So those are kind of like the secret sauce of the business. What comes out on the other end of that reactor, and the word reactor really is a vague term, but really our reactor is really just a bunch of tubes that hold the catalyst in it, and make sure that the catalyst stays at constant temperature and pressure. What comes out of the reactor on the other side is jet fuel, which is a hydrocarbon. So it's a mixture of H's and C's, so hydrogen and carbon. And we also get water as a internal byproduct. We recycle that water back through our electrolysis process.
Okay, so that's going into the first stage right there.
Yeah, we recycle that water back through our electrolysis process so we can, use the protons and oxygen again.
Sounds like some oxygen gets in there during the reactor process then, or?
No, so CO2, carbon dioxide, has 2 oxygen atoms in it. So you got to pull those oxygen atoms off. If you're starting with CO2 and hydrogen and you want to make a hydrocarbon, you have to pull those oxygen atoms off of the CO2.
And so that oxygen reacts with the hydrogen to make water.
Exactly. Yeah. And it has to. I mean, that's the first law of physics is conservation of mass, conservation of energy. So you're not going to create or destroy any oxygen atoms when you put them into the reactor.
Right. So it's coming out as a liquid, the fuel.
Yeah. So what comes out is a mixture of water and jet fuel, right? And on the bottom of this mixture, it's like if you take oil and you put it on top of water, right? The oil will float on top, like olive oil on water. The olive oil will float on top of the water. That's very much what comes out of our reactor. It's an oil layer, and that oil layer is the jet fuel and the water layer underneath it.
Okay. And now, I imagine, I know that you guys have done calculations in terms of how much, for example, CO2 is converted into a metric ton of fuel or something, and then, but the primary source of the power that's making all this happen is electricity. So, is there a way to easily explain how energy efficient this process is? I don't know if you could compare it to something or to talk about, I guess the overarching question is, what is if you take this entire process and you do it and you come up with jet fuel and you take that jet fuel and you burn it.
Yeah.
Right. And then that carbon goes back into the atmosphere when you burn it.
Yep.
That entire process, that entire life cycle of all of the electricity that's used to make it, all of the materials that are being done, and then eventually the burning and the carbon coming back. Is that an actually carbon negative process, or is that carbon neutral? How do we calculate this?
It's carbon neutral. It's fully circular. And the argument that I pose to many people, are that if you're making a fuel, something that's going to get recombusted, you can, by nature, you can never be carbon negative. It's impossible because you're recombusting the fuel. The carbon's going back into the atmosphere. Mm-hmm. The best that you can possibly do if you're making fuel is break even, is be neutral. That's not the case when we make chemicals. So, when we make other products out of our process, For example, at Air Company, we had a byproduct stream from our process that we used to make ethanol. That ethanol, we got FDA approved, and we sell that as a vodka product and a fragrance product. Those products, or fixed products, things like plastics or other things you could make from carbon dioxide, those can be carbon negative, right? Because the carbon is going into a fixed application on planet Earth. The carbon is leaving the atmosphere and it's going into like a solid or a liquid, right, that stays on planet Earth.
And the vodka goes into your body. That's a much more complex and larger cycle there.
We did get asked by some folks, the vodka goes into your body, and then most of the ethanol turns into acetate. That gets urinated out. The acetate goes into the natural acetate cycle. And the natural acetate cycle is something that's in oceans and all over the place. And essentially, it's like a tree. You get the same amount of carbon sequestration from our vodka as you get from essentially planting a tree. It's called biospheric sequestration. So you're sequestering the carbon that was in the atmosphere in the biosphere.
That's interesting.
If you make plastics, though, for example, those plastics are permanent sequestration. For better or for worse, plastics obviously have their own environmental problems.
Oh, that's an entirely other thing. That's an insane one, which we'll get to, actually. I've got some interesting questions for you about that. Real quick, though, the electricity that you use to do this, how much power does it take to go through this whole process and create a metric ton of this kind of fuel?
So we're the most efficient technology in the power to liquid space. So it does not take us nearly as much power as it takes other people. Mm-hmm. That being said, there's about 12 in a kilogram or so of jet fuel. There's around 12 kilowatt hours ballpark. That varies a little bit by where you get your crude oil from or how you refine it. But rule of thumb is in roughly a kilogram of fuel, you'll have around 12 kilowatt hours. In order to make that fuel with legacy processes, you would need to put in around 50 to 60 kilowatt hours. So the overall efficiency of the process is, sub 20%. With our process, you only need to put in around 25 kilowatt hours. So that's to go from the water and the carbon dioxide to the finished fuel. So our process is a pretty big step change in improvement in efficiency over other processes you could use to make liquids from carbon dioxide, water, and electricity.
So it's about twice as efficient, it sounds like, almost.
Okay. Yeah, you could say it's about twice as efficient.
Okay. Big question for you here then. Why isn't all jet fuel already being made with this process?
Technology A takes time to scale. There's a lot of reasons why all jet fuel is not being made with this process. I would say the one that I just mentioned is actually probably second. The first one is economics. It is cheaper to dig in the ground and get your jet fuel for free. You dig in the ground, crude oil comes up. I mean, it's actually cheaper than if it grew on trees. So the first question is economics, right? Fossil fuels right now are cheaper than renewable fuels, and that's across the board. Natural gas-fired power plants and coal-fired power plants still generate the majority of the electricity we consume as a species. We do have solar and wind power and nuclear and other sorts of low-carbon electricity, but they're not even used, as broadly as the fossil fuel resources are because fossil fuels are cheap. The reason why fossil fuels are cheap is because the societal cost of burning fossil fuels is not priced into the fossil fuel. So all the fossil fuel companies and, fossil fuel groups in general are getting a great deal right now. They dig in the ground for something. They get it for free. They have to refine it maybe a little bit. So they have to build some infrastructure to refine it and transport it. But they don't have to pay for the societal effects that burning the fossil fuel and even extracting the fossil fuels cause. Pollution from extraction or pollution from, not just carbon dioxide emissions from fossil fuels, but also nitrous oxides, sulfur oxides, particulates, things like that. All sorts of negative societal effects of fossil fuels are really just a discount for them.
Would it be possible to theoretically price in these negative externalities and compare the price and the process and the price of your, for example, your jet fuel to compare to fossil fuel jet fuel? If you were able to like pull these negative externalities in, have you done anything like that before?
Yeah, we have. So we've priced in the social cost of carbon dioxide, and our jet fuel is competitive with fossil fuel when you price in kind of all of the externalities. I think the reality of it though is that those externalities are not priced in. So if it takes us, X number of dollars per gallon, and that's more than the $2.50 that you can buy the fossil jet fuel, it's just a really challenging economic story. So I would say the biggest hurdle to deploying these technologies is that the social cost of fossil fuels is not priced into the price of fossil fuels. So right now, fossil fuels companies have a huge subsidy that we as a species are kind of giving them in order to extract fossil fuels from the ground and burn them in the atmosphere. That being said, there are also, so that's kind of the first and the biggest hurdle. That being said, there are also other hurdles where you have to scale technology. You can't just go and build a, multi-billion-dollar plant. You have to scale that technology in order to get to the point where you reach sufficient economy of scale to be able to come down in price. So that's a challenge that we can tackle today. And that's a challenge that we are tackling today. There are credits, tax credits that came into play with the Inflation Reduction Act last year that try to price in some of the social cost of fossil fuels by giving a credit to fuels made by other means. And so when you factor in things like the hydrogen production tax credit and the sustainable aviation fuel blenders tax credits, if they are implemented properly, then we can be cost competitive with fossil fuels. But again, that's if they're implemented in a way that is, properly acknowledging the benefits and value to society that power to liquids chemical production has.
Taking those no, you're good. Those tax credits out of the picture.
Yeah.
Let's just talk about technology and economies of scale. What would need to be true in order for your technology to be cheaper than fossil fuels?
So independent of the tax credits, first we need to scale the technology. And scale up is in a lot of cases harder than discovery. We need to scale the technology from where we have it. Where we had it a few years ago was in a laboratory. Now we currently have it in a demo plant. So that plant takes up around a 500 square foot facility in Brooklyn, New York. Beyond that, we then have to take the technology and build a first of a kind small commercial plant. And that's what we're doing right now as a business. So all of our efforts really at Air Company are focused on building this first of a kind plant. When you build the first of a kind plant, there are inherent risks. No matter what the technology is, there's always risks to being the first to do anything. So when you build this first of a kind plant, you typically don't want to build a massive plant, because if you're going to build a plant that has any risks in it at all, you want to minimize the amount of money that you have at risk. So we're building a small commercial plant that's going to be the first real commercial demonstration of our technology. So we have a small demonstration plant, but this is really going to be the first plant that makes things at these economic scales, makes our jet fuel at these economic scales. Once that's demonstrated and people have seen the process operating on like the millions of gallons per year scale, then it's much easier to go out and build 30 million, 50 million gallon per year plants. One of the challenges that we face doing that, once we get to that stage, is we need to make sure there's enough renewable or low carbon electricity out there in order to deploy all of our technology. So renewable electricity has to become more widely deployed as well.
That was going to be my next question, is what let's say we take the equation and take electricity as one of your factors and turn that cost down to nearly zero. Let's just say fusion, explodes or something along those lines. And if electricity becomes exceedingly cheap, does this totally change the entire equation for you guys as well?
Yeah, if electricity is free, then tomorrow we're cheaper than fossil fuels.
Okay.
So yeah, if the electricity is free, then we don't even need any subsidies. Then we're much cheaper than the equivalent fossil fuel. Because then it's just the operation of the plant, really, and the capital equipment to build the plant. So lower cost electricity really does change the game for us. The places where we're deploying right now, specifically, where we're putting our small commercial plant and where we have kind of preliminarily sited for larger commercial plants, are places where there are an abundance of electricity on the grid. So places where the price of electricity sometimes goes negative. And electrical companies really don't like it when their price goes negative, and then they have to pay money to make their product, and they have to pay money to sell their product. So we do have, a lot of deployment opportunities, but when the price of renewable electricity really gets low, that's where we have deployment opportunities that are in great abundance.
We start getting those loss lists. There's all that technology coming out now, or news about.
Don't get me started on superconductors.
Yeah. We'll just have to wait on that one.
Yeah, we'll see how that goes. If I had a nickel for every high temperature superconductor, I wouldn't have to talk to venture capitalists. I'll put it that way.
That's awesome. Well, this was something that was interesting to me because, in Type 1 Planet, we've had many actual episodes that have to do with carbon resequestration and electrolysis. And actually, we're going to go into creating food out of CO2, which has been a theme on the show as well. But electrolysis itself is not a new technology. And one thing that crossed my mind was, why is it that Air Company is different or better than other companies that might be doing this? And one thing that really stands out is your branding. And, you mentioned you have vodka and perfume and other, they're basically luxury brand products, and they're branded almost as luxury brand products on your website. And so you go on your website and the branding is gorgeous and it looks like a luxury brand. So let me ask you, where was the inspiration behind making your brand look like this? What was the kind of impetus in relation to your mission?
Yeah, I mean, the mission of the business is to scale technology, right? And we knew going into it that our technology was going to be more expensive than the fossil fuel version. And so we had to make high-value products, right? When it costs you $1,000 to make a gallon of a product, of your ethanol, for example, you have to find a way to sell it in a way that is going to make you more than $1,000. And so that was where the vodka and where the perfume, were born from. My co-founder has a background in luxury consumer goods. So he actually worked at Diageo, the largest spirits company on the planet.
There it is.
Yeah, he was like a corporate executive at Diageo prior to to working with me on Air Company. And those products really they serve many purposes. Obviously, first, they're a way that we can monetize our liquid as we scale up our technology when it's really expensive to make on the small scale. Second, they really demonstrate our ability to put a product in market and sell a product. I think we're the only, company in this field that has products that you can go on the internet and buy right now.
Mm-hmm. Unless it's sold out. Just saying. The vodka.
The vodka sells out very quickly. The fragrance we have, that I know we have fragrance in stock. I just checked this morning. The fragrance also sells out, but not as quickly as the vodka. That also the value of the fragrance to us is, on a per milliliter of liquid basis. It's if you do the math, right, a 50 milliliter bottle of a fragrance sells for a couple $100, and that's not just us. That's a lot of premium fragrances.
I've heard that premium fragrances is like the most profitable business if you can get the economies of scale right.
That's one of the reasons why, we look to go into it. I mean, obviously we're not at that scale yet. We're not making, money hand over fist from our perfume, but we're using it to get to that scale. Every penny of any product that we sell goes straight into research and development for carbon technology. And, it helps us come down the cost curve so that we can in the future produce these products at a much lower price point. Now you can actually think about it. Kind of like what Tesla did. Tesla made the Roadster. It was a fancy car for rich people. But the point of the Roadster for Tesla was not to sell, Roadsters forever. The point of the Roadster was to generate revenue so that you could have an early proof point of your approach and of your technology, so that you could then go on and scale your technology and come down the cost curve and make things at much larger scale that allow you to have much better individual unit economics. And they did that. The Roadster was this expensive car for rich people back in the early 2010s and things like that. And eventually they were able to figure out mass production, and now you can go out and buy a Tesla for a more reasonable sum of money.
What's your mass production product other than jet fuel? Hand sanitizer, what's, do you guys have anything down the pike that you're thinking ahead and thinking we could do it on scale? That's what we would do.
Yeah, I mean, so we produce liquids from carbon dioxide, and the technologies that we have focus around alcohols and sustainable aviation fuel and sustainable fuels. So really anything you can conceptualize as being made from alcohols or the sort of paraffinic and aromatic kerosene type fuels are products that we know that we can make, and they're products that we may be announcing in the future. So all right. We haven't yet announced a lot of them, but we know that there are a lot out there.
Nice. And this may be even a question for your co-founder, but in terms of the branding, there's a lot of emphasis that's put on the design. And it seems that even, for example, you have a blog on your website, and conceptual design is a big part of many of the posts on that blog. One of my favorite ones where you have packaging concepts. There's void, store, and decay are three different kinds of packaging concepts. And there's a quote actually from your website that I love. It said, void, store, and decay highlight three different ways to think about sustainability. These experiments are entirely speculative. Without the constraints of actual production, we can create forms that defy expectations. That was I thought that was beautiful for a couple of reasons. But I wanted to ask you, how does that philosophy of designing the idea before actually designing the means, does that come into the way that you look at these gigantic projects, and the way that you design the big picture for your company?
Yeah, I mean, it absolutely does. I mean, one of the major things that we need to do in order to sell sustainable products is to show people how they're sustainable and show people how they're being made. Sustainability and this ties into why design is kind of at the center, one of the center points of what our company is doing. Sustainability is not something like, this product tastes better, or this product, does XYZ better. It's not something that you can look at a product and inherently know that it's sustainable. Whereas, for example, if you look at you can look at a lot of different products, a car, for example, and, know certain things about that car, or that looks stylish, or, that fulfills my need for this product. Sustainability is not it's not like a tangible physical property. So sustainability is more conceptual in people's minds. It's a real thing, right? There's too much of this physical thing being emitted into the atmosphere, then the atmosphere should reasonably have in it at this certain time, given other, geological atmospheric constraints. And if we keep doing that, we're going to cause a lot of problems for humanity. So, it's a real thing, but it's not something that, you can't look at a product and immediately tell whether or not that product is more carbon friendly than a corresponding other product. You have to tell that story to consumers through design. And so that's one of the reasons why we have these, conceptualized products, why we have kind of a team that does that at Air Company, is to be able to tell that sustainability story to consumers. You can actually, again, I think that's one thing that Tesla and maybe a few other companies that are in the sustainability or in the clean tech space have done particularly well. And the design aspect to it really is about telling the story to consumers that conveys the sustainability or the minimalistic approach that we take to making our products in the first place.
Art and design are such an interesting component of futurism and of even science fiction. And by the way, I'd like to know, are you a fan of science fiction or
Yeah, oh yeah.
Yeah, books, any series that you love or anything like that?
I've read a handful of book series, I would say like a while ago, but realistically, that in the last I would say like 7 years since I was doing Air Company, I've been really haven't had too much time to do leisurely reading. So I'm definitely behind on reading and things like that. But I would say back. I'd read kind of like the Abaddon's Gate, which is like turned into The Expanse, the TV series, of course, yeah. And a few others as well. Yeah.
And these incredible works of art are, truly inspiring to the human race. And we, eventually our form starts to match the fiction that came before it. And that's why I enjoyed, for example, these packaging concept posts, because they were saying, this is just a completely non-existent object that we're using beautiful 3D rendering to present to you. But someone can look at that and be like, oh my God, that'd be so cool. So it's just wanted to give kudos, and I hope that whoever's doing that on your team keeps cracking at it, because it's beautiful.
I appreciate that. Yeah.
Yeah. So I did have questions about barriers to mass adoption of this kind of technology from the Air Company. And we actually covered a lot of it, talking about the scaling, the electrical component. But I wanted to kind of ask, in terms of the mission and kind of the future thinking strategy, are there any ideas or any behind the scene conversations happening in terms of implementing this sort of technology in countries that don't have access to fossil fuels, that, somewhere down the line, if the following is true about our scaling, we might be able to bring this technology on a global scale, in even potentially in some sort of philanthropic scale, to be able to bring accessibility of ethanols and fuels to countries that don't want to be under the thumb of, let's say, another country that produces fuel by drilling it, things like that. Have you ever had those kinds of thoughts or conversations in the back end?
Yeah, actually, I have that. I have those kind of thoughts and conversations, probably even more than I do the climate change ones. I actually, in the past, I've been on, on maybe a podcast or two, or or an interview or two, where the threat of climate change was not really something that was tangible to the interviewer or to the audience. I don't, I think I don't, personally, I think I disagree with them from a scientific perspective, but I actually have plenty of friends who are pretty strong climate change deniers. And a lot of those people are still huge supporters of Air Company. And the reason why is, because it's not just a matter of climate change. While I think it is, a huge driver for what we do, fossil fuels are the cornerstone of energy independence. And so to many people, Air Company is really more focused on energy independence than fighting climate change from a story perspective. And realistically, I think that checks all those boxes anyway. So that's one way that you can get people who, think climate change may be a, hoax invented by another country or one of America's competitors, to agree with someone who thinks that it's the most existential threat and it's going to, be hugely catastrophic in the very near term. Getting two people like that to agree, and I would say like I probably sit more on the climate change as an existential threat side of it, but I don't think I actually don't think that it's going to be a super near term extinction event. I think that it is people are very bad at predicting timelines. But that being said, even if you look at the climate models, the really awful effects of climate change aren't felt until 2050 and later. If we continue emitting fossil fuels at the current pace. So even climate models say that it's not like we're going to have the end of the world next year. There are still decades to go where things are definitely going to get a lot more unpleasant, but not going to be hugely catastrophic immediately. The problem is we want the world to be around quite a bit longer than 2050. I'm hoping that I live that long. I think you're probably on the same page. And, for everyone's children who are without a doubt going to be around at that time, you don't want your children to inherit a hellscape. And so that's really, I sit kind of on that side of the climate change argument where we're not doing this for ourselves, we're doing this for our children. And our grandchildren and, the future generations. There are people, of course, who don't think that climate change is a threat to anyone at any point in human history. And while I disagree with that opinion, many of them will agree that energy independence is a major issue that has already caused several wars. And to the people who don't really prioritize fighting climate change, the fact that we can now make a system that we can deploy in anywhere in the world that can make the resources that you need to get from fossil fuels today, that means we can take the control of energy resources away from the small groups and small, I would say small number of people that control them currently, and give that energy or control of your energy source to the masses, to the people, is something that has a huge potential to change the way that society works and help people who are from more disadvantaged backgrounds and disadvantaged countries, be able to be self-reliant, be able to have a voice for themselves, because they're no longer reliant on someone else for their energy. And everybody needs energy to live, even if you even need energy to eat. 2% of our not quite 2%, but near that of our global greenhouse gas emissions comes from like fertilizer production for food. Without energy, you can't even eat. And so the people that don't have these energy resources are really at a disadvantage. And it's energy security. We're able to give that security to people, by having technology that creates the resources that today we need to use fossil fuels for.
We use the phrase democratization of knowledge a lot in terms of the Type 1 Planet model. And I'm now thinking about adding democratization of energy.
Yeah, absolutely.
To be able to, and listen, for the people out there who might not, who might have the perspectives that Staff was just referring to in terms of global warming and are hesitant or skeptical, you have to agree that having the ability to produce oil or capture oil from the surface of the earth, being in the hands of a very small amount of incredibly rich people, is not helpful to the rest of the world. And if we are all able to create our own fuels, like the same way we can capture sunlight now with solar, I can go out and buy solar panels. It's expensive, but I can do it.
The price will come down.
Price will come down, right? And it's interesting. So, one of your slides, I actually asked you this at Venture Clash when I met you. One of your slides on your deck for your pitch had a big picture of Mars on it. And I said, why do you have that big picture of Mars on? Because you didn't talk about it in the presentation. And you had an answer then, and I'm going to ask it again now. What does the air company have to do with space exploration?
So Mars is a really interesting case. Over 95% of the atmosphere on Mars is carbon dioxide. And Mars has water resources on the surface, mostly ice water, but some, the potential to make liquid water. Even with ice, you can get the protons out of it. Air Company actually was the very first bit of support we ever got from a government agency at Air Company was from NASA. We won their carbon dioxide conversion challenge. The reason they even had a carbon dioxide conversion challenge in the first place was because when you get to Mars, you have to be able to make things, because getting things to Mars is really hard in the first place. So if you can utilize the resources on the surface of Mars to make things, then all of a sudden, rather than having to transport a bunch of stuff, all you have to do is transport one thing that makes stuff out of those resources on the surface. So we're part of what you'd call NASA's in situ resource utilization, or ISRU, system. We actually currently have a small contract with NASA that we're doing some research. On, and that's publicly available information. So Mars is actually really important to Air Company's business because in applications on Mars, you're a lot less price sensitive. So I was just saying the biggest barrier to everybody in the entire world using Air Company's technology is economics. In outer space, the economics are different than the economics on planet Earth. So we can make systems and make them work in outer space, and we have a lot more freedom in terms of the cost that we need to hit per gallon of product. And we're not actually, the playbook that we're using for this is actually an age-old playbook. We didn't invent it. You mentioned solar panels. 50, 60 years ago, it wouldn't be feasible for you to go out and buy solar panels to put them on the roof of your house. It would be like, it's expensive today, but it's still something that, a lot of people can afford, or you can reasonably get a lease to lease the solar panels, and, they'll pay for themselves after 10 or so years. That was not possible 50 to 60 years ago because the cost of solar panels was astronomically high. It was so high that normal people could never imagine owning a solar panel. But NASA needed to power space stations and satellites. And the cost of powering space stations and satellites, that's a much less price-sensitive market than people putting something on the roof of their house. So solar panels commercialized, they use space as their early adopter, as a way to commercialize the technology at an early stage because space was not as price-sensitive. So
this has happened for many technologies, actually, is space exploration has caused the invention of more efficient technologies. It's interesting.
Yeah, absolutely. Yeah, so like solar panels, we see Mars as an opportunity for us to deploy our technology in a way that is less price sensitive than trying to compete with fossil fuels here on Earth.
And then you don't have to carry your return flight fuel on your way there. It makes it a little easier, a little lighter. That's your fuel when you get there.
That's exactly what the contract we currently have with NASA is actually to make rocket fuel on Mars. So, we send a system over to Mars, we make the rocket fuel using the water and the carbon dioxide in the atmosphere on Mars, and then a manned mission happens and your first astronaut lands on Mars, and they don't need to worry about having the fuel to get back because there's already a fuel depot with a full gas tank that they can just put into their vehicle.
Is there, you don't have to tell me details, but is there even a timeline that exists where that is a reality?
I mean, there is. I can't tell you the details of that timeline. I think we're already making the fuel. Just, I think it's very public knowledge that we actually, last summer, we flew the first ever aerial vehicle with 100% CO2 derived Jet A.
And that was with the DoD?
That was with the U.S. Air Force. Yeah, it was a small drone. And that was in July of last year, July 27th, I believe. And we demonstrated that you can do it with the fuel that we make. Now it's a question of miniaturization. It's a question of making it flight ready. It's a question of making it more efficiently because you don't want to waste any resources in space. So it's just a question of improving efficiency. So it's the difference between, it's improving something from 1 to 10, right? But the difference between 1 to 10 is a factor of 10. The difference between 0 and 1 is a factor of infinity. And we've already gotten to 1. So we've already crossed the infinity threshold, and now we just have the factor of 10 to go.
Crossing the infinity threshold. I love it. Let's just talk a little bit about food, because your team won a NASA Deep Food Space Challenge. I think, was it last year or something like that? Tell me, what is that challenge that you guys did?
Yeah, the Deep Space Food Challenge was another
space food challenge. That makes more Deep Food Space Challenge.
Yeah.
All right, I'm not sure what I wrote.
It's some real deep food.
Yeah, such deep food. This would be deep.
I ate that food and contemplated for 7 days straight. The Deep Space Food Challenge was a centennial challenge put on by NASA to demonstrate creation of food that is suitable for deep space missions. So using essentially only the things you have available to yourself in a deep space mission. So carbon dioxide is available, right? You breathe it out. Astronauts breathe out carbon dioxide, and if you have more than a few thousand parts per million of carbon dioxide in the atmosphere, it's toxic to humans. Like, it's a toxic gas. That's a whole nother issue with the carbon dioxide levels rising in the atmosphere that we didn't even get into. But it's much more acute on a space station because there's a limited amount of space. You're breathing out carbon dioxide as an astronaut, and that means the carbon dioxide in your atmosphere is rapidly increasing. So all space stations have to have a carbon dioxide removal system. They called it the Carbon Dioxide Removal Assembly, or CIDRA, on the International Space Station. And so that means you have pure carbon dioxide. And when you're on a deep space mission...
Do they keep it on currently, or do they spray it out into space? Do you know?
They have tried many different things to transform and reutilize that carbon dioxide, because in a lot of cases they just have to spray it out to space.
Okay.
It is obviously a loss of mass, and when it costs you thousands of dollars to get 1 kilogram of mass up to your space station, you don't want to jettison anything. But NASA has actually tried a system where they would rip off the O2 from the CO2 and make water out of that. And from the carbon, they would make methane. And that way you're conserving some mass, right? O2 is most of the mass of carbon dioxide. CO2, carbon has, an atomic weight of 12. Oxygen has an atomic weight of 16. So carbon's really only like 27% of the mass of carbon dioxide. Most of the mass of carbon dioxide are the oxygen atoms. And so NASA built a reactor that would rip those oxygen atoms off and reuse them and make water out of them to reuse the water. So you could save some of that mass. So that's had varying degrees of success. What would be better is if you could reuse the carbon too and fully reuse everything. And that's what we did. We made our alcohols from carbon dioxide, so essentially our vodka. And then what we did is, rather than obviously just like giving the vodka to an astronaut and saying, hey, good luck. Cheers. Yeah. We took the vodka and we fed it to yeast. And the yeast that we use is actually, you could buy this yeast on Amazon. It's a very common yeast that's currently used in tons of food. We've all eaten it. But we found the particular one that can eat vodka and make more yeast. So essentially make, other the other compounds that you need to have to stay alive: fats, carbohydrates, proteins.
Yeah.
And so it was essentially a nutritional yeast. But you could make, we called it a space protein shake because, it had proteins in it as well.
So that was what you made for this challenge, is you made your space shake.
We made our space shake. Yeah. And we could demonstrate that you could make it with essentially all fully circular things. So may not sound very appetizing, but in a very Martian-esque manner, we actually added urea to get a nitrogen source, because protein has nitrogen in it, but carbon dioxide and hydrogen don't. We added, a very, very small amount of vitamins and minerals that you would get recycled by people, essentially. Of course, sterilizing and purifying everything all the way along. But in the end, we were able to produce this yeast that had fats, carbohydrates, and proteins. And actually didn't taste that bad. Have you ever had seitan, that wheat glutinous vegan food? There's been a big uptick in vegan restaurants in Bushwick, in the part of Brooklyn, where I'm from and where Air Company is. And so I've had plenty of like wheat gluten based specialties, and it tastes like that. So it tastes actually pretty, pretty good, all things considered, given that it's kind of like a bit of a Martian meal.
Nice. All right, I love that. We've spoken to a bunch. We talk a bunch with a company called Allfed, and Allfed, basically they're trying to figure out food solutions in the case of a global low light scenario where we lose a portion of our crops, and then how can we retrofit existing industrial machinery to create food. And one of the great ones is that they take the CO2 from factories, run them into bioreactors, and then feed that CO2 to microbes, and the microbes feed off of the CO2, and then what you get out of the bottom, essentially, I think the waste gas is oxygen in the process, is biosludge that's high protein or whatever it is, and so it was interesting, and they were talking about trying to put that in space too. So I'm sort of making a little catalog of, okay, what are the different space foods that we're looking at with these technologies?
Yeah, you have to get energy. The big one is you have to get the energy in there somehow.
That's what I was going to ask you, is where does the electricity come from to do this on Mars or to do this on a space station?
So then you have to use either solar or nuclear or an electricity source there, right? You have to get the energy to split water first. And once you make your hydrogen, it's all downhill from there. You don't need to add any more energy in once you have hydrogen.
Mm-hmm.
If you have hydrogen, then it's actually every reaction from there on out is exothermic. So that means they all actually emit energy. You don't need to, add any energy in post hydrogen, but you do need to add a lot of energy in to make the hydrogen. And so that's where, we look toward different sorts of energy sources. In the U.S., we have hydroelectric as a large source of renewable electricity. We also have a good amount of wind electricity as well. On Mars, you would look at most likely solar. Wind is also, actually, there's even more wind in a lot of parts of Mars than a lot of parts of Earth. You'd also look at nuclear power sources, because you can transfer a very large amount of energy in a very small space by transporting a nuclear power source.
Okay. Well, we're just going to have to see what ends up happening. Well, that timeline we were talking about getting to Mars, I'm so excited to hear about it.
But we're not going to get the astronaut to Mars, but we're going to get him back.
There you go. All right. I love it. I'm conscious of your time today, and I'm so thankful for sitting down with me today. I wanted to ask you one last question, which is, if you were to have the opportunity to sit down and have a discussion like this with someone else, even if it's someone who might disagree with you, a politician, a fellow scientist or entrepreneur, who would that be and why? And should I be reaching out to them to talk to them as well?
No, I would actually I'd actually prefer to talk to someone who disagrees with me, because I don't need there's no ground gained from talking to someone who's, in full agreement with, with everything you say when it comes to things like podcasts, or when it comes to things like you mentioned government, or like things like that.
Yeah.
I think, these are a good way to have a dialogue. I'm trying to think of who I would want to. I'm on a podcast, so I immediately think of like the Joe Rogan podcast.
Sure.
But
yeah. I'll text him and see if he'll have you on. That'd be great.
No, but there's definitely other people that are definitely way more important to to talk to about this. But I don't know if I don't really know.
All right. Well, it's
Joe Biden. How about
Joe
that?
Biden? All right, deal.
You can get him.
And real quick for the audience,
he might not remember the conversation though. So
that's a completely different conversation. Real quick for the audience, where should they go to engage with what you're saying, what your company is saying, future developments, that kind of stuff?
First place is our website, www.aircompany.com. that's where we typically, will have any major announcement. We are pretty active on the only social media that I actually use is LinkedIn, and I use that mostly to hunt down prospective hires and recruit people.
You got a Twitter presence somewhat, don't you?
Well, that's all of the other social medias out there are kind of, coworkers kind of help me take care of them. So
Good for you.
the presence, the presence on other social medias is,
okay. Good.
If I'm trying to recruit a VP of for the business, then LinkedIn is probably the most utilitarian one. But yeah, Air Company has a presence on Twitter, Instagram. I never was really an Instagram user, so I'm probably least well versed on that one.
Okay.
And on LinkedIn, Twitter, Instagram, I think any other source of social media. We're not big on TikTok, I don't think. I think I'm too old for that.
Roger that. Yeah. All right. Well, I'm going to link all of that in the show notes. Staff, thank you. Well done. This is amazing. It's exciting. There's going to be a lot of questions, I imagine, from people watching this. And so we're going to, maybe we'll talk again in the future. I'd love it.
Yeah, absolutely. I appreciate it.